This video, you will learn how to perform different operations with complex numbers. We first have to understand what imaginary numbers are to understand what a complex number is. So here are some examples of square roots. Square root of 9 is equal to 3. Square root of 16 is equal to 4. Square root of 49 is equal to 7. Square root of negative 4 has no real number solution. So this is how we answer this. Square root of 4 times square root of negative 1. We know that the square root of 4 is 2, but there is no real number solution for the square root of negative 1. This value is what we call imaginary, and we label it with I. The answer will be 2i. The negative 1 to the square root results in the I. Complex numbers has a real and an imaginary part written in the form a plus bi. A real number can be a fraction, a decimal, or an integer, while an imaginary number is a value that contains a negative square root. Here are some examples of complex numbers. Negative 5 plus 2i, negative 3 plus 6i, negative 10, and 8i. Let's now perform different operations with complex numbers. In adding complex numbers, we simply add the real parts together then the imaginary parts together, keeping them separated. In this example, quantity negative 3 plus 7i plus quantity 5 minus 4i is equal to negative 3 plus 5 plus 7i minus 4i. The answer will be 2 plus 3i. In subtracting, we just have to distribute the minus sign to the second complex number, then change the problem into an addition problem. In this example, quantity 4 minus 2i minus quantity 5 plus 3i is equal to 4 minus 2i plus quantity negative 5 minus 3i. The answer will be negative 1 minus 5i. To prepare for multiplication and division of complex numbers, we have to first do the cycle of I to the first is equal to I squared is equal to negative 1, I cubed is equal to negative I to the fourth is equal to 1. The powers begin to repeat after I to the fourth. In multiplying complex numbers, we use the FOL method, or the first, outer, inner, last terms are multiplied. In this example, quantity 2 minus 3i times quantity 4 plus 5i is equal to 8 plus 10i minus 12i minus 15i squared is equal to 8. 10i minus 12i is negative 2i. I squared is negative 1, so negative 15 times negative 1, then add like terms. The answer for this example is 23 minus 2i. In dividing complex numbers, the goal is to remove the imaginary numbers in the denominator. We will do so by multiplying the denominator by its complex conjugate. In this example, 1 plus I divided by 3 plus 2i. 3 minus 2i is multiplied to both the numerator and denominator, and it's equal to 3 minus 2i plus 3i minus 2i squared divided by 9 minus 4i squared is equal to 3 plus I minus 2 times negative 1 divided by 9 minus 4 times negative 1 is equal to 3 plus I plus 2 divided by 9 plus 4. The answer is 5 plus I divided by 13.
We hope that this video helped you.